Hi learners, welcome to the today's topic. Our today's topic is problems related to the analytical processing. Myself Priyanka Gupta, I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. Now we will talk about what are the key ideas of Olap, what is basically online analytical transactional processing. So that is having the other operations. So what are the problems related to that? And what is the solution on the basis of particular those Olap operations that has having the different operations, that is roll down, roll up, drill down, drill up, and pivot table, as well as the slicing and dicing. Let's start. So the key idea for the that Olap operation is that what is Olap basically? So basically Olap is converting the data into the information for the decision makers that is needed. So why we are going to use the Olap, that is going to convert the data into information from the data warehouse for the meeting the purpose for the decision makers. So on the basis of that, they can take the different decisions. They can take the right decision. Second is the concept is that to analyze the data by multiple dimension in a structure called data cubes. So all the data will be stored on that data warehouse in the form of some multi-dimensional data cube. So the data cube will be having the different dimensions. So if we are telling the multi-dimension, there can have the more than 3 dimensions also. So dimensions is nothing but that is having the one dimension of particular each property. So what is the need of Olap there? Why we are going to use the Olap? What is the need? So the key driver of Olap is that the multi-dimensional nature of the business problem. So the business problem that is having the multiple columns, that is having the multiple we can say related dimensions. So that on the basis of that, we have to make it as a one single dimension or 2 dimensions from the different dimensions. So on the basis of that multi-dimension nature, the Olap will be needed, and we can see the different view of the particular data cube in the form of particular something operation, some related operations. So that will be the logical view of that particular data cube. That will not be in the physical form, that we can see in the form of logical. So now these are the problems will be characterized by the retrieving a very large data set. So on the basis of that is the large database in the data warehouse that is having the number of records. So that can have the gigabytes, we can say the petabytes, terabyte data. So on the basis of that, the business decision people, so the business decision makers, they have to find out the something related, something informative, we can say some of the dimensions. But on the basis of that large databases, these are the Olap operations are there. On the basis of that, we can see the particular one dimensions also. So these are the problems will be categorized by this retrieving the particular dimension from that particular large database. So that can reach by the terabyte and database, and after that has been going to summarize that data into the information that is useful information that can be used in the form of we can say in the form of we can say graphs, in the form of particular reports to the business analyst, we can say end users. Now the limitation of SQL is there, that because these are the things, these are the databases can also will be there in the relational database. But what is the use? Why we are using that type of data in the data warehouse? That can be done by the SQL syntaxes, that we can also retrieve from the SQL syntaxes in some lines, few lines. But there is a limitation of that. So that we are using the Olap operations. So the SQL limitation is that it cannot represent the complex problems, because there have been the larger database the relational database that is having the small databases, that will not have large databases. So that is the limitation of that. A query will be translated into the several SQL statements. So there we have to write the several 4-5 line SQL syntaxes. So that query will be translated into the statements. Then only we will able to see the result. So these of the SQL statements will involve that can have the multiple joins. We can say intermediate tables, sorting, aggregations, and temporary memory to store these of the particular tables. So these are the tables, therefore that is going to use the Olap, that will be preferable, and that will be the kind of solution of that particular SQL problem. So because of the limitation of SQL, we are using the Olap operations. So the business questions, that is not easy actually, that is based on the huge complex queries. So the question become the more complex and we can say multi-dimensional. So we are taking the Olap operation. So now we can see one example, one question for that, one problem for that. Then we can understand that how we are going to apply the Olap operations. Let's take a question. So now here in the right hand side, we can see the Olap cube that is having the 3 dimensions. So there is 3 dimension. X dimension is having the different, we can say, these are the weather. These are the weather that is having the spring, summer, and autumn. In the other X, we can say X axis, we can see the there is a Glasgow, Newcastle, and London. These are the 4 we can say cities related to that particular. Some of here in these cells there are some numerical values are there. Here in the Z axis we can see the socks, jumpers, t-shirts, and pajamas are there. So these are the 3 dimensions of this particular Olap cube. That is 3 dimension. So in this cube we can observe the each side of cube that is going to represent one of the element of the question. So the here for the x-axis that is going to represent the term, the y-axis going to represent the product, and the z-axis that is going to represent the different centers, right? So in that we can understand these of the 3 dimensions. So the cells of in this cube that is going to represent the number of product that is going to sold or representing by the price of an item. So that are the price of that particular items, right? So it can be observed that as the size of the dimension that is going to increase, the size of the cube will also increase exponentially, right? So if the size is going to increase, the size of cube will also increase. So the time response of that cube depends on the size of particular cube. So that is vice versa. Now that's why pre-aggregation is needed. That is valuable because the dimension of the cube that is can be hierarchical, that is in the form of hierarchical. So for example, time can be divided into the half, years, half month, quarter, and days. So like this the time can be divided, so the aggregation will be needed, pre-aggregation will be needed. Now the predefining such as the hierarchical relations can allow for the smooth drilling down and the pre-aggregation. So that will be needed earlier to the while we are going to show the solution. Now in this figure we can see here that is the drill down, that is a drill down of that particular table, particular cube, data cube. So in the drill down we can see the total sales in the descending order, total sales per city, total sales per city per store, total sales per city per store per month. So that will be the drill down. What will be the drill down? That will be the total sales per city per store per month. Now the total sales per city per store, total sales per city, and total sales. So that will be the drill down and drill up. So this figure gives a different understanding of the drilling down operations. These are the related to analytical processing. The relations defined must not be directly related. That will be related. If they will be directly related, What counts it? Defining the relation. So the size of cube can be controlled by handling the sparse data. So if there will be sparse data, we can and on the basis of sparse data we can manipulate that particular data cube. So not necessarily that all the data in the cube must have the meaning. So all the data cannot have the meaning. Some of the data can have some meaning. Now in the marketing database, 95% of the cells are empty and can contain zero value, right? If that is data related to business purpose, so that can have the zero also. Also in handling involves handling duplicate data of the cells. So there can have the duplication of the same value. Let's assume that the cost of one product, one value for all the markets the company is dealing with. Therefore, it is not necessary to have a cube with a multiple data item. So the cost of item will be same for a particular one market. So that will be not necessary to make a sense to to make a particular data queue for that. So dimensional hierarchy, sparse management, and pre-aggregation. These are the three tools will be there to speed up the execution of multiple dimension query while we are going to write the queries to drill down, drill up, roll down, and pivot and slice down and dicing. So that will be going to give the multi-dimensional query and reduce the size of the databases. So on the basis of dimensional hierarchy, sparse management, and pre-aggregation, these are the three tools we can have the aggregation of any type of multi-dimensional queue. Now first we will take the roll-up. So roll-up is the also we can call as a aggregation or consolidation. So the roll-up operation can be performed in the two way. So how the roll-up can be working? That will reducing the dimensions. So the dimensions what is having the more dimensions, we can have the view of in the form of few dimensions. So climbing up the concept hierarchy. Concept hierarchy is a system of grouping the things based on their level of order. So in the hierarchy, we can combine the two of the dimension, three of the dimensions that will combine as a one dimension. So that like that we can reduce the dimension for roll-up. In the Olap operation, the roll-up is very, very important. So in this figure, we can see that is based on the roll-up operations. So if the city is there, so on the basis of city, if we are going to see the some of the operations, some of the view of operation. So if the city can be converted in country, so that will be combined as few of the cities will be combined as a country. So that will be reducing the dimension. So on the basis of that particular location from city to country, we are going to see here we can see the item type is there, time quarter is there, and here the location city is there. But while we are going to roll up, while we are writing the roll up operation, we can see the view in the form of location city. So that will be reduced as a city. So that is the importance of roll up. Now in this example, city New Jersey and Los Angeles rolled up into country USA. So the sales figure of New Jersey and Los Angeles will be combined, that will be aggregated. So that will be 440 and 5060 respectively, but they become 2000 after the roll up that we have seen in the figure. So in this aggregation process, data is location hierarchy moved up from the city to the country. So in this roll-up process, at least one or more dimension need to be removed, and in this example, city dimension will be removed. Now we will take the drill down. So how the drill down operation is working. In the drill down, data is fragmented into the smaller part. So in this, it is the opposite of the roll-up operation. It can be done via the moving down the concept hierarchy. So it is the opposite to that roll-up. So it is increasing a dimension. So here we can see the broad view of that particular dimension. So what we have done in country, in city we have made the country that will be aggregated one dimension, but here we are we are not covering, we are removing that dimensions, we are increasing one dimension. So here on the basis of quarter to month, so if q1 q there will be 4 quarters in a year, so quarters can be shown in a month. So quarter will have the January, February, March. So three months will be there, but that can be shown in the another dimension, that is increasing a dimension as a month. So in this, drill down can be happening like this. So the cube were small there, but that has a large view now after the drilling down. So in this example, quarter Q1 is drilled down to the months January, February and March. So that was the quarter Q1. So corresponding cells are also registers. So that has been changed to the other dimensions. In this example, dimensions month is added, as that was earlier it was quarters. So that was all about drill down. Now we will take the slicing. So here one dimension will be selected, a new subcube will be created. So that is a logical view of that subcube. So this is a 3D dimension of that particular data cube, but we can have the slice of one dimension that will have the 2-dimension view of that particular slice. So following the operation diagram, it explain the how slicing can be operated. So dimensional tree, the dimension time is sliced into the Q1 as filter. A new cube will be created altogether. So here from this, the slicing for time is equal to Q1 we have taken. So we have got this particular slice that is having the item types, and that is having the cities, that is having the New Jersey, Los Angeles, Perth and Sydney. And so that is a particular one slice of that 3D multi-dimensional data cube. Now we will take the dicing, how the dicing operation can be occurred. So this operation similar to the slicing. So in slicing we were taking the one slice from that particular 3D as a 2D. So the difference is dicing is you have to select 2 or more dimensions that result in the creation of a subcube. So here we have to take in the form of 3D. So in the form of 3D we have to take a dice. Dice, if we are we can relate it to the dicing play we are actually playing now. So like that there will be the 6 dimensions, right? So like that we have to take the 4 dimension that is having that is having the 3-dimension dice. So on the basis of dice, the location, so the location, 2 of the location we can check the Perth or Sydney, Perth and Sydney, and as well as we can write the claw with write the syntax time is equal to Q or Q2. So like this, some of the more items, some of the more aggregation we can use. So that will be that in the basis of this particular 3D data cube, we have found this dice of that particular related what we have written as location and time, and we can also have the 3rd dimension as item, that is having the books or cloths, right? So in the 3 dimension we have got this dice. So like this we can write we can have the subcube of that particular 3D cube. Now the pivot table, in the pivot we can rotate the data axis, that is going to provide a substitute that is that is having in the form of presentation of data. So in the following example, the pivot is nothing but that is having the rotation of data. So that is the pivot is based on the item types. So on the basis of here we have seen the item types and location city. Now we have we are going to rotate, we are going to pivot that particular data cube, that is a 2D, that is a 2D cube. So that we are rotating it as in the pivot that is on the basis of city. So the city will be there and item types will be there. So like this we can rotate the particular 2D data cube in the substitute representation. This is the only presentation that is not occurring in the original database. That is only the logical view of that data. So that pivots will be will have been the based on item types. So that was all about the how we are going to do the Olap operation, that is related to analytical operations. So that was all about the Olap operations. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.